program in a way that we can actually sort of theoretically talk about. So that's one part of the work. The other one is that not just there's sort of things we can project into the context, but there's also we also want to understand how the program uses something. So maybe if your program is calling some service and you have to pay for the service, you want to check that you're not calling it too many times. So you could add these annotations to your type system that are somehow going to capture how you're dealing with the context. Or if you can track what kind of things that are available on my phone am I actually using. And then depending on that, when you install the application, you can ask for permissions. So there's two ideas here that I want to talk about. One is this idea of how can we check what we are doing with the context that our application uses, and the other is how do we actually get more useful things from the world around into the programming language. And I'll start with getting more things into the programming language, and that's sort of generally work that I've been mostly doing with people in Microsoft Research, with Don Syme, on F# and type providers. And it's the idea that we can integrate external things into the programming world. And I think one nice way to talk about it is when you're using Google and you search for something like population of London, Google will actually not just like complete with all the possible things you might be looking for, but it even gives you the value immediately. And I think this sort of experience with working with data is something that fairly recently appeared with the web and Google and so on. But it's not something that you get when you're in a programming world, because when you're programming, you kind of say, well, now if you sit down in your Emacs or Vim and you're like, now I'm going to get the population of London, you really don't know where to start, sort of. And so what we are doing with type providers is we are trying to make the external things in the context available in the programming environment in a way that's sort of similar to the one that you get with the Google search. And I'll just show you one example here. So I'll have to open, so this is just referencing a library that I'm going to be using, and the demo that I was working with, showing before, is using this data source called World Bank, and World Bank is an international organization that distributes aid to developing countries, but they also have a really nice data set of various indicators about the countries. And what you can do here is when I go worldbank.countries, it actually comes with a list of all the countries. So what's happening, there's a few things happening behind the scene. One is that the editor is actually running the F# compiler in the background, so it knows the types of everything. And when I do dot, it offers me the members of the type, like methods. And the other thing is that there's a type provider running in the background, which is a sort of a plugin into the compiler in a way that provides the types on the fly. So when I type dot, it actually went to the internet, called the World Bank, got a list of countries, and now you can see them here. So
how does it know where to go, or does it just go to Google, or?
So this one, that's a good question. The World Bank one is sort of specifically for that World Bank data source.
Okay.
So that one can only give you data from that one that one data
But could you
set.
just call Google directly?
Yeah, it could call Google and give you the search results.
Yeah, okay.
They're kind of hard to parse, but yeah.
Yeah.
I'll show another one that's more general later on. Yeah?
What if that list changes before runtime?
Yeah, well, so if the list, that's another really good question. What happens when a country disappears? Like, I was born in Czechoslovakia, and there's not there anymore. So if a country disappears, so if you take write your program, compile it, country disappears, you run it, you get a runtime exception. And you sort of, when you look at it, I think it makes more sense to compare it with a situation where if you were writing it without this feature, you'd have to write something like worldbank.search and then string Czech Republic, and if that returns null, you get a runtime exception. But one result I'll show later, or talk about briefly, is that for some of the type providers, we can actually give you some sort of relative safety property. So we can say, if the input doesn't change in certain ways, it will work. If it changes in bad ways, well then we can't give you anything. Right, so that was the first bit. Let's have a look at UK. And it goes further than just to countries. You can actually see all the indicators here. And I'll just hold page down for a bit, because there's really a lot of things. It sort of does very limited search, so, but I think if we go for GDP in local currencies, or no, I like the school enrollment in primary, let's go for this one's good. So central government debt, and so now that was just providing the types, and here I can actually run it. And if I call a list of C function, it will give me all the actual data. So what's happening here is that I just write this program and then I can run it, which compiles it and runs it. So now it was running the compiled program, and you can see how the central government debt of the UK has been changing over the last something years. So it's going up, which is probably a good sign.
Really?
No.
For the bank,
Well,
yes.
depends.
Is list a reserve word?
Sorry?
What are you programming in? What is this?
Oh, this is the F# language.
Not sure. So list is a reserve word or not?
Which one?
List.
No. So,
I have no idea how list gets wb.countries related to it.
so this bit here is just using the dots to get members.
I got
of
that.
some
I got
object.
wb.countries out
Yeah.
of here. I got that.
And then this bit here,
Yeah.
the funny operator, is a pipe.
Oh, you're
which
piping the
takes-
output of that to that.
Takes the thing on the left, passes
And then
it
you
to
pipe that
this, and then passes that to line.
Pipes it to the list.
Yeah.
So list is a...
So that was sort of one example of how you can take one specific data source and put it into the types of the language, and there's sort of this already shows quite a few of the interesting questions that you get when you start doing it, which is what is actually sort of data and what is some schema. Because with the World Bank you could say, well, actually maybe the countries, they don't, or maybe the indicators are part of a schema because they never change, but the countries are data because they change, or the years are data, and you get like list where the years are just numbers, or alternatively we could also change it so that it gives you .2016.
I'm just thinking, sorry, I'm just thinking, for instance, with Czechoslovakia, it would have been nice if it didn't actually change, because if you wanted to find out data between 1980
Yeah, yeah,
and 1990,
yeah.
would have been.
yeah. No, I think a lot of these actually sort of aren't just programming language questions, but they're also the data source questions. So there's for example, data source where they can give you a snapshot of the data as it was on a specific day, and then you can sort of deal with a schema change just by saying I'm going to use this as a fallback or something. So a lot of it is sort of interaction with data as well. From the sort of general programming language perspective, there's certain things we just can't solve without some support from the data source, I guess. The other fun problem here is when I typed dot, this schema was fairly simple because I only had countries and then indicators. But there's also various graph databases of like graph knowledge databases where it's actually a really complex graph with something like hundreds of thousands of different entities. And there used to be one, but they shut down their API quite unfortunately, where you could go freebase dot, and then it would tell you like sports dot baseball dot whatever they do in baseball. And the sort of interesting bit there is that it's just so huge that you can't run the whole projection at once. So what type providers are doing is that they only sort of explore the part of the type that you're using in your program. So if I never looked at the concrete indicators, it would never actually get to them. And one problem that I was working on that's I think interesting is this sort of idea that so the World Bank type provider is really nice because it gives you really nice sort of types for one specific data source, but it's not very useful in general. Because in general, you'll be calling things that return XML or JSON or CSV or some sort of other data format, and you want to be able to work with that as well. So the type providers, they can also be parameterized, and I took this sample URL here, which has my private API key, in case you need it. And then you can put query equals city, and it can give you a better forecast. And if I run it, it prints this thing here, which is some JSON formatted data, which, yeah, I'll have to parse it somehow. And the normal way of working with these things is that you just go to the website, find the documentation, run some parser on this, and then look up in the structure it returns to find the thing you want. And what I can do here is to say, call a JSON type provider with this URL as a sample, and it produces a type called weather, where I can now use the type to work with data sources that have a same structure of response. So first of all, there's a getSample method. So what I did is that I defined my type, and then I'm calling getSample to actually run it, download the URL, and parse it. And then you can do w dot, and you'll see types, you'll see members that are actually generated based on the sample data I got here. So this contains, and it infers what these are. So here you can see this is some sort of city object, and we get the population, the country, and then there's some list of things. So if we iterate over the things, then there's for one day we have weather. This is some sort of collection. I think temp is what I need. The daily temperature. So this is the weather forecast for Prague. The interesting bit here is that you sort of this sample, that's something that the compiler has to know at compilation time. So you can put in basically only a constant. It could be a constant URL, or it could be a name of a local file that you downloaded. But when you run it, when you actually run it in your application, the user might enter the city that you want to look for. And so I can write load, and rather than looking at Prague, let's look at London. And if I run it, it still works and gives me the weather forecast for London, because the service returns data in the same format for all the different places. So again, there's some sort of interesting assumption here about the data source, which is that it can give me, like if I look at one sample, the other data that I'll get for different requests will have the same structure. And that's what the sort of schema inference algorithm here is doing. You can give it one sample, which is what I did there. You can also give it multiple different samples if you know that the service returns different results for different requests. And then it tries to generalize from them and find a representative type for this sort of data. Yeah?
So just to, just so I understand, because I'm not familiar with FSAR.
Yeah.
So when you say type T equals JSON provider, sorry, type weather equals JSON provider, that is evaluated at compile time.
Yeah.
So
Well, yeah.
And it is fixed, so that query doesn't happen at runtime. You don't have a runtime type there.
Yes, that's correct.
Okay.
It happens. So this bit is sort of processed at compile time.
Whereas your module references are runtime. So the dereferencing a modules when you say weather dot something, that happens at compile time. At runtime.
Yeah, yeah. So this bit of code runs at runtime, and at compile time.
No, I mean actually when you say weather dot load, that is evaluate.
Yeah, that is just runtime.
Yeah, so that generates a sequence of sort of dynamic requests to open the module and get the load, get a pointer to the load function or something.
So, what
I'm trying to mesh that with your previous example, which obviously you know, if the country disappears, how so you need some kind of dynamic loading, I presume, in that.
So what happens is in the World Bank example, it produces code. Well, when you type something like World Bank of Czech Republic, that gets compiled down to some runtime representation of it, and the runtime representation will be something like World Bank lookup and then string Czech Republic. So the nice types that you're working with, they're actually erased during the compilation. So they're used for the sort of, for when writing the code and when compiling it, but then they disappear, and at runtime, it's just does some JSON-based REST service calls. And it does the same thing here. So when I write t.temp.date, it actually just says on the underlying document, do a lookup for a field with this name. Yeah, that's a good question. Yeah.
So, it's probably a simple answer. The results of that, I can't work it out. Because there's 7 there, and I thought it was for 7 days. And then I looked above, then I thought, no, it's not. And then it doesn't match the temperatures for min, max, norm. So I couldn't work out
So
what the
is
results were.
Yeah.
Because you're asking for a particular day, not for a week.
Oh no.
So-
So this call, I think, gives me data for the next week.
Oh, okay, so that's 7 days.
So that's 7 days.
And what's the M for?
And sorry,
9.91
9.91.
centigrade.
So that is the daily temperature for the first day in my list.
Yeah, but YM.
Oh, YM.
Okay.
M is just because the numerical type it's using is
Oh, is
decimal rather than float. So
M is for
M will
Is a
just be there.
data type in,
Yeah.
in F sharp. I didn't.
Yeah. No,
Okay.
the M is silly and doesn't say anything.
Okay, that's the.
Yeah.
I got the 7 days and now.
It's not like 9 million centigrade. It would be too hot. Even for London.
Thank you.
Yeah, thanks. So there's this schema inference bit is fairly interesting because it lets us use the type providers not just with one specific data source like the World Bank, but the JSON one that I was showing will actually work with any service that returns JSON in some reasonable format. So there's sort of assumption on how the schema is preserved between different requests, which in practice works pretty well, and we can sort of formalize it and say what exactly are the conditions there. So roughly the way it works, when I have two types, so the way it works is that I load your documents, and if you have two sample documents or like a list with sample things in there, we'll try to find one type that's a common, and now which way is it? Subtype or supertype? I think it's a common supertype, yes. I never remember it. Yeah, I'll be finding a common supertype. And for primitive types, so if you give me, I think my arrows are wrong way around as well. So if you give me int and decimal, so decimal was the one with m at the end. If you give me a floating point number and an integer, then I'll just give you a floating point number, because floating point number can capture all the values of integers. We're losing some precision here, so it's definitely a design choice. I could just tell you it's either int or a float, but we just say for numbers we'll always give you one type, but if you have a sample where some field can contain either string hello world or 92, then we're just going to find a type that's like a union of the two, and then you'll have to process it in a more difficult way. So I can show it here as well, because I can use this JSON provider and give it sample inline. So the triple quotes will just let me put anything in there. If I say hello, let's have a record where field is hello, and then in the other one, field is 42. Then when I do get samples and look at the first one, I can see this field, FLD, that's there. But then I have to say, do I want to try to look at it as a number or as a string? And both of these are option because it can fail. So this is where I actually unified two different samples. One is the number, another is a string, into some type, newly created type that gives me access to both of them. If I change this one to some float, then this is now inferred as decimal, which is a precise numerical type with decimal point. And the floats are imprecise, and I would only use them if it was too large. So that's what we are doing with primitive types. And there's other bit where what to do if you have records, where one record has some fields and another record has some other fields. So if I have person who has a name and person who has name and age, I could tell you it's either that record or that record, but that would be pretty hard to program against. So what we are actually doing here is that we merge the shared fields, so you'll get person with name, and then the age will become optional. So it's sort of trying to produce a type that in the programming informal sense you can always do dot and you'll be able to access the things there.
So how does this work with object-oriented programming? So if I drop it, if I have a subclass, I've got a type already and I define a subclass of it, it's dynamically typed at runtime. Is this an issue for you, or is this...
I've already got that provided with constructors.
There's no question I can do all this stuff, one way or another. My question is, how does it fit in with your type checking questions?
So I'm only looking at, so this is only looking at JSON and XML types, or XML and JSON documents, where...
You've got a general framework for superclassing types. So it's a lattice of types somewhere or another. So I'm wondering how something orthogonal to that is dynamic typing with object-oriented programming. So this is, classes are...
Yeah.
Yeah. Is that entirely just...
So this sort of world with data is completely sort of orthogonal to the programming language world.
So you don't care about object-oriented programming? Particularly, I'm not being critical.
No, I'm not.
Yeah, it's not an issue for you.
We actually could do that. That would be sort of another... So the way we are doing it currently is that we have this world of data, and then we define these subtypes on the data.
Mm-hmm.
And then we have the programming language, and there currently we're just ignoring subtyping.
Mm.
But you could also sort of map some of the subtype relations in the data to subtype relations in the program, in the programming language, which could actually make quite a lot of sense in some cases. Yeah.
Okay.
So there's a few other things. So if you have like two lists of things, one with num and one with str, then we just sort of union the types of the elements of the list. If you have two things that just don't match in any way, then we'll give you this ugly type where you have to choose which one you're accessing. Which surprisingly, I was really surprised by how well this works in practice, because the data that JSON services or XML documents usually contain are actually fairly regular. So I think there's probably more work to be done there on some sort of empirical evaluation. How many of the untyped, unstructured data are actually really structured. And there's so we sort of have one paper about it where the key result at the end is this relative safety property for these JSON and XML type providers, which pretty much says if I use something as my training, as my sample data set for the inference, then when at runtime I give you any value that's a subtype of any of your samples, all your code that you wrote using the type will work.
Does this safety properties proven in the standard way with preservation and progress?
Yeah.
So the procedure to prove that is the standard.
Yeah,
on
it's
type
progress, preservation, proof. There's sort of, generate, we have like a calculus that represents what's your mini F# program, and that takes this data value, which could be anything, and in the end you'll reduce to an F-sharp value, and that reduction is guaranteed to produce a value if there's some condition on your data holds. Yeah. So that was the one part, and I can give you more links later on to find more if you're interested. The other part goes in the other direction that I was mentioning in the beginning. So the type providers are sort of adding more stuff to your context. It's extending the types that you can use in your programs to work with things from the world. This line of work is more looking at how can we actually more precisely track what you're doing with the things that you have in the context. And there's, so how many people here have heard or played with affect systems? Yeah. So affect systems are, or it's sort of the same thing as monads in Haskell. They're sort of a way of saying what my program does to the world when it runs. So in affect systems, you're writing programs by saying in a context gamma, expression E has some type, and it also has effects represented by the sigma. And when you have a language with affect system, you can say, when I write this program that prints to the console and reads from a file and produces a number, it's a program that has type int, but it also has effects of reading from file, writing to console. So you'll get some sort of over-approximation of what it might do when it runs. And that's what affect systems are doing, and then there's the sort of formal semantic side of it, which is captured by monads. And what we are adding is something similar, but for talking about context. So I'm going to say, if I have all these variables in gamma and some additional context, we'll say exactly what that might be later, then an expression has some type. So if I have a program that needs the GPS sensor, then I could say in some context gamma, and another annotation that specifies I need a GPS. My function call get location will return int and int. So if you look at just these two things, they're really just predicates with 4 placeholders in them. So they formally it starts as looking very similar, but there's actually sort of interesting non-symmetry in programming, where if you talk about results of programs and the inputs of programs, it's not fully symmetric. So it will break in various interesting ways. We call it coeffects to sort of illustrate or to say that it's something that's in a way dual to effects. So effects are always talking about what your program does to the world. Coeffects are talking about what your program requires from the environment. And there's a nice quote from Phil Wadler's paper that talks about the lambda abstraction. So when you're creating a function in a language with effect systems, he says in the rule for abstraction, the effect is empty. So creating a function does nothing to the world, because evaluation immediately returns function. It doesn't do anything else with no side effects. And the effect of the function arrow is the same as the effect of the function body. So when you write a function that says take n and print n to the console, that's creating the function is effect 3, but when you run the function, it will do all the effects that are captured by the function body. So with effects, there's this interesting property that you can always delay them and capture them and have them encapsulated, and that's where coeffects are different. So I'll show you just two examples of what you can do with coeffects. One is this programming language, and I'll actually now I'll start with the slides, but I have a nice demo in a web browser as well. So what I'm saying here, I have these question mark parameters, like question mark culture, and I'm writing a function called print that takes a number and then calls some print number and gives it the number I want to print, and then current culture. So it could be things like NUS for the American formatting of numbers, or if I put the Czech culture there, it will print commas rather than dots, that sort of thing. And then format is another parameter that specifies like how many decimal points I want. And the idea here is these things aren't like a normal function parameters, so I didn't have to specify them in the input of the function. They just have to be provided somewhere in the context. And that could be when I'm defining the function, or it could also be when I'm calling the function. So the culture parameter, that's already set when I define the function, but the format isn't. So the typing rule that's used here actually says if I have body E, that's of some type, that requires some additional implicit parameters, then I can type it, I can split those into R and S in pretty much any way I want, and some of them have to be available when I define the function, and the rest has to be available when I call the function. So I do have a nice website that actually has a JavaScript implementation of this. Where is it? There it is. So if I use the example from there, where I said, I'm just going to do integers. So there's one integer is set to 10, and then I create a function that adds